Oh, hi guys! What's going on there? Today we're going to talk about the Joule circuit. So let's get started. Let's just say we want to turn on an LED with it, with a AA battery. But as you can guess, the voltage of this battery is too low to turn this LED on. So we need two of them at least to make things interesting. But of course, buying one battery is more expensive than just buying one. But somehow we need to turn this LED on. And this is where the circuit comes in. This circuit contains a center tapped coil, a resistor, and a transistor. Now if I insert the LED in, we can turn on the circuit and you can see it does light up. And I literally made up from scrap. So it's even better. But how is this circuit really works? Let me explain it with a little animation. Let's just say we have our battery. Let's connect a coil to it. When we connect the coil, current starts to flow through the inductor and thus they store energy. When we open the circuit, however, its polarity flips and wants to keep push the current. But because there's no path that would conduct, it's going to increase its voltage in order to make the current flow. But in this case, the voltage is going to be so high, it could be able to destroy something. That's why you see a spark when you switch an inductive load. And that's the back EMF voltage. Now we can change the switch into a transistor, so we can electronically turn it on and off continuously at a high rate. Like this, we're constantly making pulses of high voltage, and that's enough to tinkle your fingers. Ouch! But in this case, we want to turn on an LED with it. So we connect an LED across the transistor. Like this, our coil is going to become another voltage source, which means that we have high enough voltage to turn the LED on and thus it starts to glow. But this circuit needs a generator that generates at least the square wave that turns on and off the transistor continuously at a high rate. And that's what this Joule circuit is for. We have a coil that's center tapped, and its center tap is connected to the battery. One outer terminal of the coil is connected to a resistor, which is connected to the base of the transistor. The other one connects to the collector of the transistor, and the emitter is connected to ground or to the battery. And like this, our switching mode power supply is done. And that's basically enough to drive an LED with it, as you can see in this small simulation. Now we can scale up this into a scale that now can do things. Here we have the same circuit as this one, but it's more powerful and it generates a high voltage. You might say now, this is dangerous, don't work with it. But we're talking about a high voltage that's low current. High voltage, low current supplies are much safer than high voltage, high current supplies. And this circuit can easily turn on this neon lamp I lay around. Now let me show it to you. As you can see, it does turn on. Now you might just say we can just easily plug it in into the outlet and thus turning this neon lamp on like this. and it does still work. But of course, poking into an outlet can get dangerous for people who doesn't know electronics at all. And that's where the low voltage power supply comes in. It basically steps up the high voltage. It basically steps up the low voltage, which is 5 volts, onto a voltage that's enough for the neon lamp. And I forgot to mention, to turn on neon lamps, we need high voltage. So like this, we can now turn it on. Now this is the same circuit as the other one, but this circuit, it's a bit different, because instead of a center tapped coil, we have a center tapped high voltage transformer. We have also an additional capacitor at the output to limit the amount of current that can flow. Thus, we can also turn on neon lamps that has absolutely no built-in resistors at all. So yeah, and as you can see, this circuit uses a more powerful transistor because it dissipates too much power. So we need a heatsink and a more beefier resistors. So yeah, that's it. And it does work fine. Just for fun, let's just see the LED again glowing from a low voltage source. You cannot see it much, like this. And this circuit is good to test out the neon lamps, like this one here. If I don't know if it does work or not, I can just plug it in, turn it on, and if it glows, then it's good. If it doesn't, it's going to short out. Okay guys, thanks for watching this video, and you must check out my other videos. That's really worth to watch it, though my videos are Hungarian language. Anyway, you are going to translate it. Thanks for watching, and see you soon later.